Hello, everybody. So we're almost to the halfway point. Today marks the last session for Module 3, and then Module 4 starts on Wednesday. So, oh wait, I guess we still have a week. Oh, sorry, I said that backwards. Today marks the last day for Module 4, and then Module 5 starts on Wednesday. So kind of the halfway point. Still got a couple weeks left. Game development is very time consuming, sometimes at times, but this class is mostly about familiarity with tools. Right? We're in very tight time constraints, so mostly what we're looking at here is assortment of tools, trying to get the general idea so that when you have some time to sit around and click around on the interfaces or throw some scripts together, you have somewhat of an idea of what to do with it. So we'll finish up our coverage on Game Maker today. Just kind of the rest of finish out that little game we started the other day. I sent a file out a few minutes ago. I think the only one that didn't get sent out last Wednesday to finish up what I had in mind on that quick pass was a sound effect. So I sent that out this morning. And to get that sound effect file, I just went to Google and said explosion sound effect and went to a site that had lots and lots of free sound effects. That site also has a lot of paid for sound effects, nicer ones, all different qualities. But there's lots of places to get resources. We don't necessarily have to make them. There's a lot of them out there. We'll see that a lot more when we get into Unity, which we'll probably go ahead and get started on some stuff with that today. I don't think it's going to take us that long to finish up our Game Maker example game. And I had a note here in the to-do stuff about the Chapter 7 exercises from the textbook. And Chapter 7, I think, is the last one that has questions. And you'll notice that Chapter 7 is all about the design documentation and spreadsheets for keeping track of the project, as the project's ongoing. And then the exercises are basically about creating some of those. So on the homework assignment, well, another homework assignment is to tell me what you plan on doing for the course project, what game you want to make. And you might remember that instead of trying to work in, figure out something small that can fit in our time constraints, I wanted you all to be able to make the big, interesting games, or at least work on the big, interesting games that you probably already have in mind. The ones that definitely aren't going to fit in our time constraints and would take a team of people. And that's where the documentations and stuff come in important. So for those Chapter 7 points on those questions, it's really about the documentation stuff. So those points are going to come just sort of as freebies when you turn in the project proposal, because that's what the project's about. That paperwork and the plan for the project, and for our class here, since I want you all to do the big, interesting things, there's going to be a lot of planning and putting together the team assignments and the general structure of the game, the storyboard of it, maybe some artwork, and just a proof of concept, which is just a couple levels of the game to prove that it's going to be a fun game. And then the paperwork that you can just hand over to a team to basically fill out assignments, and then the team can sit down and make that big, interesting project most of us probably have in mind already. So the Chapter 7 exercises kind of relate to that. So they go over the format for that. Chapter 10 as well will be a big one on the project. So from the textbook, Chapter 7 and Chapter 10 are kind of the two big ones that will relate to the project. So the points for those questions are just going to come with your proposal, telling me about the game you plan to make, scheduling out your time, how long you think it's going to take, what you're going to do for the proof of concept part, like what sections of the game, maybe a couple levels and a cutscene, cutscene or something just to show what your game's going to be like, and that it's going to be fun, and then plan out the story for it and how it's going to break down into different levels and things like that. So chapter 7 and 10 are big parts on the project. So that's really the exercises for that relate to the project proposal this week. And then any of the game engines that we look at this semester will be fine for making the proof of concept thing, right? Even if your plan is for a big, huge 3D thing, because we're under tight time constraints, your proof of concept could be a stripped down 2D version of it, just to a sampling of the story and a general idea of what the artwork's going to look like. Is it trying to get realistic artwork, or is it very cartoonish? And just something to give the idea of it is what a proof of concept is. So any of the game engines we look at this during this course will be fine for your project, whichever one you want to use. Game Maker is very intuitive. A lot of people find it intuitive, easy to use, and things are clearly labeled. It's a great one for learning game logic. So after we finish up our example here, we're going to move on to Unity, which is one of the two biggest ones. I guess it's a matter of opinion whether Unity or Unreal is listed as number one, but it's a very, very popular engine. It can handle a lot of stuff, so that also adds a lot of complexity and at times complication into the user interface. But we're going to start looking at it, start to get familiar with that. But Game Maker can be a lot easier to work with. So in the long run, it might be good to keep Game Maker around and come back to that to practice the structure of game logic. It's been around for a long time, and pretty much everything that it does, they have a scripting language there, but pretty much everything it does is in that interface. So you can see all the clear labeling from hovering your mouse over buttons and see the parts you have to work with, and practice putting things together there in Game Maker, and get the general ideas and the structure of game logic together in that simpler setting, easier to work with setting, I guess. And yeah, especially for 2D games, if you're just making a 2D game, Game Maker can put that together a whole lot simpler than Unity can. But we'll look at Unity soon. We want to finish up our coverage of Game Maker. Does anybody have any questions before we jump into that?
I don't think so, no.
Okay, so I'm gonna go ahead and share my screen, and we'll get back to where we were the other day on that. One thing about game engines in general is there's a lot of temporary files along the way. Well, the interface-based game engines, because those interfaces they're writing code in the background. All computer programming is still done primarily text-based. So a lot of the interfaces that we have to work with write code in the background. So there's a lot of temporary files that will fill up a flash drive. And here on my PC, I'm very quickly running out of local storage space. So I'm going to work on a flash drive. So if you're working on some software like that, as more and more things move to the cloud, we can save a lot of money by, like I did on this PC, buying the ones that don't really have much local storage space. And we save everything on the cloud somewhere. But when we need that local storage space, we might run out of it on those things. So you can just plug up an external hard drive or a flash drive or something. That's what I did here, that has enough space to work on, and work on that instead of your the hard drive running out of space, because it's just it'll write all the temporary files there where you're working at, and then they get deleted at the end of the session anyway. So I copied everything over here. That way I don't run out of space on this computer today. But here's what we started the other day. And hopefully it won't be too uncooperative with the Zoom call. It was going kind of slow the other day. And one of the things I had on my list was to try random numbers, like that guess a starting point thing I've mentioned a couple times, and then refine it from there. You will get very good at estimating distances in pixels very quickly. It's just like any other judging distance. Assuming that you're good at judging distance, some people, if you're not very good at judging distances to begin with, and estimating distances in pixels is the same thing. If you have trouble telling what an inch is by looking at something an inch long, then that's going to carry through when you're trying to estimate a distance based off a different unit. But you'll get kind of used to it, and if you're one of those people that has trouble with that, you can just grab a piece of paper and put some lines on at a certain number of pixels, like 10 pixels or something, and just mark out, make you a little ruler really very easily to get a more accurate sense of it. But a lot of times it does come down to guess a starting point and adjust it, because some things, there's a lot of complexity in video game development. And that's kind of what I was thinking Game Maker is good for, to learn how those pieces go together in this more intuitive situation, see how things are, because there's a lot of interaction, a lot more interaction between pieces than we have in our other, I guess, business-oriented software. It is very common to be tracking down a bug, trying to fix something in your game, and discover that that bug is in a part that you didn't even think was running there, just because things are so interconnected. It's like, well, that object's not even in this room. Why is that causing a bug here? Is that there's just a lot of interconnectedness, and practicing that in a 2D situation can be useful to get used to the structure of game logic. Because when we scale that up to 3 dimensions, it's not always 1/3 bigger, right? Or 50% bigger. Because some things might be on that axis, but a lot of things are going to go off the plane, not the axis. Right? We're working on, in 2 dimensions, we're working on the XY plane. So when we scale that up to 3 dimensions, we don't have just one more plane to work on. We have our XY plane, the XZ plane, and the YZ plane. So scaling it up triples those interconnected issues. So 2D things that are easy to work with are a nice place to learn the structure of game logic. So here's what we had the other day. We brought in those animations from our past on 3D modeling, just a little dragon, add in a fireball and a picture of a castle, and then a background sprite. So loaded in our images first. And then we set up this dragon object. I need to switch to the other mouse. A regular mouse makes a big difference here, because in our work area, there's scroll bars all over the place. So actually having that middle scroll wheel where we can click, hold the middle scroll, and to get panning, or control in that scroll wheel to zoom in. And if we hold control and scroll, then it zooms to wherever the mouse is. It can be very useful. So we set up our dragon object with a couple of events. If we push the enter key, we'll check if an instance exists. So there's our branching structure. You might remember from the SDEV 120 class, one of our 4 constructs for problem solving, the basic tools for programming in general is some sort of selection structure. And here in Game Maker, those are going to be marked in green. And the sequential tools in programming are almost trivial, because it's the order we put our instructions together in. So if we have multiple steps, we'll connect with blue lines saying this one, then this one, then this one, the sequence they go in. And whenever we put in a branch, our example here was just a one-way branch a yes or a no thing, it connects everything that happens on that branch of our flows through the program with the green line. Color coding can be useful. So we just, when we press the enter key, if there is not, so the negation is just a check mark. So if there's not an instance of that fireball object already on the screen, we'll create one. We don't really want the player to be able to just spam the key and constantly have fireballs. That makes the game a little bit too easy. Right? As developers, we want to be on the player's side. We want the player to win the game. But if it's too easy, they're going to get bored. If it's too hard, they're going to get mad. So there's that, we have to find that balance and make it, add in little challenges, but try not to make it too challenging where the game becomes impossible or anything. And then we looked at where that tried to generate it relative to our dragon. Again, just a check mark here, and then adjusted it by pixels so that it looked like it came out of about the right spot. Just looking at the process here. And on our other events, we also have a space event, and that switches our dragon from walking to flying. So when we push the space bar, the animation switches to flying and it just jumps up, which is one of the things we'll fix today. One of the last things in the game, but that seemed like a good starting point. It just jumps up by 200 pixels and then goes to the flying animation. And vice versa, when we release the key, it jumps down by 200 pixels relative to its position and switches back to the walking animation. So that was our dragon animation. We put our dragon object and we stuck that in there. And we need the fireball object so the dragon can destroy the castles, basically. So we created a new object, which here in Game Maker, just right click and there's assets and all the things we can create. Most of our stuff's going to be objects. We gave it a sprite. And when it's created, the fireball is going to do the same thing every time. It's just going to shoot out of the dragon's mouth and down towards the ground, down towards hopefully the castle if we aim correctly and stuff. So we just set some sort of speed and said to go in that general downward direction. And it's a fireball, so we also added in this what to do when the animation ends. And notice there's a couple ways we can see our things. We have tabs to switch back and forth between them, which might be a little more intuitive. Or over in the event list, we can just double click and it'll pop up to this one. So at the end of the animation, go ahead and destroy the instance. And from the little drop-down menu there, we can either destroy the thing itself, which is, in this case, would be the fireball, which is fine here, or some other object on the screen, or every object on the screen. We have different options, but the fireball is just going to kind of burn itself out, basically. We got that far, and organization is very, very useful. So I like to kind of line things up, set them up somehow in some sort of organized fashion to be able to get back to them and keep track of what's what. I guess now that we have a fireball, the next step is probably destroy the castle. Before we do that, I'm going to go ahead and give this a run. Although it may not cooperate very well during the Zoom call. We'll see. I'm going to check to make sure this isn't filling this up. So you saw it created extra hard drives and stuff there. So there's a lot of temporary files along the way. It does look a little bit jumpy, but when I push the space bar, it jumps up to the other position. Hitting the enter key creates a fireball. And spamming the enter key still only creates the one fireball. You can see those extra hard drives where it was working have disappeared. So periodically, if it starts to run you out of space, like if you have a machine like mine here where it's kind of set up for cloud storage, so there's not a whole lot of local storage space, you can just close and restart the software and it'll delete all of the temporary files that it's written automatically. So now that we can fly and breathe fireballs, we need a way to destroy our castle. So I'll create another object here. And organization goes a long way, so I'm going to make sure it's in the right folder. I'll go ahead and select the object folder and then create a new asset, a new object for our game, which is going to be the castle. And there's that animation for the destroying it, but I'm just going to do the still animations for that. We'll start with it full, start with the castle fine, and then jump to the castle destroyed afterwards. There is an animation that can be played along the way. It would just be probably that animation event we saw. We switch the animation, and then on animation end event, switch to the destroyed castle instead of looping the destruction thing. But we'll start with the castle just being in the fine position, and we can add an event. And this is one we saw before in Pygame. One of our key concepts is our main internal events are going to be timers, which are in GameMaker alarms, and collisions when two images intersect each other. The boundaries we set up for them indicate to the computer that those objects are in the same space as they collided with each other. So we'll set up a collision event. And when we do a collision, we have to say what object it's colliding with. So when our castle collides with that fireball object, I guess for starters, we might do add a little bit more to it later, but for starters, we're definitely going to do a little bit more to it later. I already sent out the sound effect files and stuff. But for starters, we want to switch the animation, switch the sprite for it. So whenever that collision happens, we want to switch to the castle destroyed. I think that's the single image one. We're going to check and see. We can set which frame of it is and different settings. So like if we were already on frame 5 of an animation, we can jump to frame 5 of the other animation to make them line up and stuff. But it takes a lot of time in the artwork to make them line up like that. Usually since games are going to be running so fast, it's okay to just start the other animation. Like when our character switches from a running animation to a jumping animation, we can just go to the start of the other one. But in some situations, you might want to base it off the frame of the previous animation, especially if size is an issue. And like the animation for that fireball it was changing size. So if we suddenly jump to another animation that went back to the small size right in the middle of something, that would stand out as a problem. But that option is there. So now, whenever the fireball collides with the castle, it will change the sprite of the castle. And yeah, I'm going to go ahead and run this. And then we'll come back and add one other thing here. We'll put it on the screen first. So it looked like when those fireballs launched, they landed right around, faded out right around here somewhere. I'm trying to put that castle about that spot. over on the other side of the screen. Somewhere around there. And again, it just kind of snaps into place. Right now, I'm just testing to make sure the collision works and everything. And remember, you have to be on one of the instances layers, the main instance layer, or create a new one in order to put your objects in. And our background was moving horizontally 4 pixels per frame. So that castle representing a structure, we probably want that moving with our background. I'm going to come back over to our castle object we started setting up. A little more room on the screen here. Hopefully that's not too small. And add in an event for every step of the game. Because the step is basically each frame. So at every frame, actually we can do it right at the beginning. We don't have to do it every frame. That's what I did in the test. There's more than one way to do things. I'm doing it at a create event. As soon as we create that object, we'll just start moving, which has been used recently, so it's up here on the short list. But remember, everything's categorized, so we can scroll down to the movement section and hover over the different movements, wrap around the room so that when it passes the right-hand edge, it goes back to the left edge, or if something goes past the top, it goes back to the bottom, and just sort of continually wrapping the room. Just jump to a different point, snap to some grid position, completely reverse our motion from what it was, or we can move in a fixed direction. I'll just do move in a fixed direction. But before we start moving, we have to tell the computer what speed it is. So that idea from programming that we have to be very explicit about all our steps. So that in setting the speed would need to come first in our, is the first thing. We have to say how fast to move and then what direction to move that speed in. So now when we run the game, it should kind of go with it. I'm going to hit save. Game Maker will automatically save when we hit run, but some of our game engines won't. So it's a good idea to save along the way. Save everything along the way. And just keep that habit going so you don't lose anything, because this is large software, right? You can see what it's doing to the Zoom call. And everybody in here is a computer person, right? Probably well aware that the larger software gets, the more likely that we're going to encounter crashes at times. Sometimes machines get overloaded and everything kind of falls apart on them. So there's the castle moving in the right direction. If I try to fly, oh, yep. Looked like the thing destroyed it. At least changed the image, right? It didn't destroy the actual game object. As far as the computer is concerned, it doesn't care about this screen. Right? That castle object, even though the animation shows the destroyed castle, is still part of this game. It's still in RAM. It's rolling off to the side. It's still rolling off to the side. So when we add in more castles to destroy, oh, I should wait till the video is working again. Bob my head back and forth so I can see if it's jumpy. Still pretty jumpy. Okay, so whenever there's more castles to destroy, they're all going to be kept in RAM, right? They're going to roll past the side of the screen, and we won't be able to see them anymore. This is one of the terms from a textbook somewhere referred to game space. The CPU doesn't align game space the same as the graphics of the game space, right? There's stuff happening off the screen. So we don't need that eating up RAM and slowing things down. So whenever things go off the screen, whenever that castle rolls off the screen, we want to go ahead and destroy it. And we have an event for that. So again, over add an event, and under other, there's outside room. So whenever it goes outside the room, we can come down here and grab the little trash can icon. Again, all these buttons are labeled, so we could change it into something else. We could set an alarm to do something. We could count how many castles there are, change the sprite, change the speed of the animation, lots of things we could do. Create a new one. I'm just going to bring in the destroy the instance, and well, we're on the castle object. So when it goes outside the room, we want it to destroy itself and take itself out of RAM. Quit using space and memory. We'll need that for something else. So if you're used to, well, the prereqs for this course would have been SDEV 120, which if you used that before this semester, would have been pretty much just working in Raptor. This semester it started with Raptor and Python because the textbook has a Python IDE built into it. The ebook version of the textbook has an IDE where we can type Python in. So I have both of those languages. But one of the things that has made Python so popular is it has really, really excellent memory management. Python handles all of that. When we're done with something, it clears it out. Actually, all of our most popular languages, probably at least the top 5, all have really, really excellent memory management in it. So you probably haven't had to deal with that in programming. If you use C++, you would have, it does the machine, if we're in C++, the machine is only going to do the instructions we tell it to do. So unless we tell it to empty something out of RAM when we're finished using it, it's going to stay in RAM and just waste the space. So this is something some of y'all may not have experienced before, that when we're finished with something, you want to make sure and destroy it. Otherwise, it's just going to sit there and fill up RAM, and RAM is finite. It's not as restricted as it was back in, say, 1995. Most modern computers have a lot of RAM, but we can still fill that up pretty quickly. So you want to make sure and clear things out when you're done. That's something you may not have really dealt with before, if all you've seen is Python and just kind of got started in things, but handled that for you. Because yeah, our most popular programming languages, that's one of the things that makes them the most popular, is the people who developed the language put really, really, really nice memory management and took care of all that garbage collection in the background, which is the actual term for it. We call it garbage collection. We're done with that stuff. We don't need it anymore. Throw it away. We don't need it wasting RAM. So you just want to make sure and clean things up when you're finished with them. I'm going to scroll out a little and kind of do that organization thing and bring this up here. So it lines up nicely with, as I zoom out, even if I can't read everything, I kind of have an idea of what things are in what positions. So that gets our castle, our dragon on there. It can walk or fly, shoot fireballs. And when a fireball hits a castle, it destroys it. Hopefully that came through in the video. I know it's a little bit jumpy because we're using fairly large software here. I need to restart. I should probably restart this at some time because it looks like it is working on my hard drive. When I did a test earlier, I ran off the flash drive and it did all the temp stuff on the flash drive and didn't need up the hard drive so fast. Hopefully it'll be okay. Might need to restart it. So I'll give it a run, see what this looks like. Let's see if the clean button takes care of some of that. So we had all those temp files and stuff. So if I hit clean, no, it didn't really clean it up much. give this another run, and we won't really see a difference unless you have like something monitoring memory open. If you open Task Manager and watch your memory usage from the previous run to this one, you would probably see a difference. But it's already slowing the Zoom call down enough. So probably don't need to do all that. Is that not running? Run. And I don't know why Google keeps asking me to sync that. Usually it does that once, but it's determined to sync the hard drive or the flash drive here. So fireball destroys the castle, and come back down, wait for the next castle, which we haven't put in yet. And we can't really see any difference, but that castle has passed the edge of the room, so it has now been deleted from RAM and isn't eating up our memory anymore. Yeah, usually most modern computers have a lot of RAM, but we can still fill that up, especially on a big, complicated game with lots of stuff going on. We can fill that up very, very quickly. Computers have got big, but that doesn't mean we don't have things that can still bog them down very, very quickly. So, like you all can see here from the jumpiness in the video, a game engine and a Zoom call tend to slow down my computer pretty quick. And it's a decent one. It's not great, but I've been really happy with this Lenovo for a couple years. So now we have a castle. We need probably want more than one castle in order to keep destroying them. Kind of a shooting gallery sort of game. I'm gonna come over here and look at where I put that. If I click on it and drag around. Oh, whoops. I have to go back to the instance layer. I was on the background layer, so I couldn't select it. Drag around, you'll notice that there's the coordinates of where it's positioned at. 280, 496. That sounds like a good spot. At least a starting point. We're going to refine it from there. 280, 496. So I'm going to jot those numbers down. 280, 496 is a good starting point, and it's rolling right. I already got that. So we need a way to do that, and notice our objects tend to relate to themselves, right? That whole idea of encapsulation we talked about with object-oriented programming. Everything the dragon needs is included in the dragon object. Everything the fireball needs is included in the fireball object. Everything the castle needs is included in the castle object. And creating a new castle that could be included in the castle object, but sometimes we're going to have more than just creating a castle, right? When we get to the end, I was going to suggest for lab time to take these steps and run with them and maybe copy those castle creation steps to create some knights or something that can stop the dragon at a challenge end. It's essentially the same steps, just need an animation for it and things like that. I know Andrew has a good animation for it would work for a king. Has a nice little crown on him. That come out and fight the dragon and stop at something to challenge the player from just continually destroying castles. So in that case, we'd have creation objects we'd be needing to create more than just the castle. And there's often a lot of other things in the background that we want to have go on. So usually to create those, it's a good idea to have a controller object. I'm going to create a new object. Make sure I'm in the right folder for the organization, but that's just a file explorer. We can drag things around, rename those, and all that. I'm going to create a new object and call this one controller. So like not the joystick controller, the game control. Maybe just control object. But something to handle all that background stuff. It's background, so we don't need a sprite on it. We don't need any sort of image. We can just uncheck the box for visible. I'm just going to not give it an image that has the same effect as unchecking that box. And again, we have control. We can turn things on and off. So we could give it a sprite and turn it on and off if needed. And then this will handle all of our events. So no sprite. And I want to randomly generate castles. Some do that with a timer. So the example of our other main internal event. So we'll add an event. We'll add a create event because we want to set that timer to begin with. And we'll scroll over here to the things about that event. As we scroll through here and look for them, this common stuff, I'll scroll down. Oh, there's this thing that looks like a clock. Looks like a little alarm clock. And that's what we use to set our timers in GameMaker. So we have several to work with. Let's go back over here on the events. Notice that alarm event, there's 11 of them, and we can add more if needed. But 11 timers cover a lot of stuff because that's 11 per object. So it's not 11 timers in the game. Every object can have 11 timers until we have to add more. And then adding more is just renaming it. By default, they're named 0 through 11. We'll set 0, 11 to some amount of time. And I'm just going to treat this as the, sometimes, right, if it's been a while since we worked with GameMaker, it might not remember is like, okay, is this timer in seconds or is this in frames? And that's an easy thing to check, right? Let's check like 3, or, well, I'll set a random number because I know I want a random number, and our syntax for that, I don't want them coming out evenly. Then the player just kind of goes into a pattern. We want to switch that up a little. Our syntax for that is going to be random range. And notice when I start typing, it gets a whole bunch of predictive stuff. So some random number, get some speed, or a random range, a minimum and a maximum. So maybe somewhere between a half a second and 2 seconds. That'll probably work. So random range, and we want something in between, well, I'll do 1 and 2. That's probably easier to type in here. So, like, okay, I can't remember if that's going to be frames or seconds, but if it's frames, it's going to be very apparent that either one, right? Typing in 1 and 2, that's going to make it very, very apparent whether it's 1 frame or 1 second. So if I save that, oh, before that'll work though, we want to make sure and add our controller object to the room. There's no sprite in it. You just drag it anywhere in there. There's no image to show. So we'll set an alarm. And then we need to add an event to define all the things that will happen when that alarm goes off. So we'll add an alarm 0 event. And in this case, we want to create a new castle, which instances refer to objects. It's an instance of our object. So the light bulb is the create one. So we'll create a castle object, which we can dig through the folders. It's a lot quicker just to search for it. Create a castle object, and then I checked and wrote down the position at 280, 496 is what it looked like my mouse was at. Which was giving me the coordinates of a big square, not a single point. So that might still need adjusted. There's some exact spots on the screen that should start right where the second one is. On our instances layer, we can add lots of layers. We're not really going to see that in class here, just kind of look into the basics. But basically, we'll just create another one whenever that alarm goes off. So if we save that and give it a run, it's actually probably going to freeze everything up. Because yeah, going over that point of guessing the timer and seeing whether it's frames or seconds. This is going to create a lot of castles very, very quickly. So I'll probably just close it, but it's going to freeze things up because it is frames. But the point I wanted to make was sometimes we just have to guess. If we can't remember, instead of going and looking that up, make an obvious guess. Make a big change and see what happens. Which that's probably not going to, that one's probably extreme for a Zoom call. Uh-oh. Wrong number of our, so got an error. And well, we haven't seen this yet. So down here at the bottom, we have this tab for compile errors. At line 5, wrong number of arguments for the alarm set. So if I double click that, set alarm 0. For some number, random underscore range. Oh, maybe I'll give it a bigger range. Let's say between 4 and 5. I'll do 20 or 30, 20 to 40. Maybe that's what it wasn't like. Because I know it's frames, so that'll probably freeze up the Zoom call, but like, okay, I can't remember if it's seconds or frames. So if I set it to 20 to 40, that will definitely be able to tell the difference between seconds and frames just from seeing it. Let's see if that runs. Oh, I don't know if you all could tell. I double clicked on the error message and it went right to it, but it was already on the screen, so it probably wasn't as so obvious that it went right to it. But the compile error thing there does link to where the error occurs. So it looked like it showed up pretty quick. A lot quicker than 20 seconds, right? And everything's jumpy from the Zoom call and slowing down. But we should see another one show up pretty soon here. Oh, wait. There's not going to be another one show up pretty soon. I did forget something. So here, when we create this, we're going to set our alarm to go off after 20 to 40 seconds. And we saw that happened really quick. And then when the alarm goes off, we're going to create an instance of it. But then we probably want to set the alarm again. So we'll create an instance of the castle. And then we can reset that alarm to go off after another of that same amount. We're in somewhere in the random range of 20 to 40, which is too small, but that way we can see that it's too small of a number. Because that's something different software is going to handle differently. So as you jump between using different tools, it's easy to lose track of which ones measure in seconds or milliseconds are normal time scales, and which ones measure in frames of the game. So it showed up pretty quick. It's showing up way quicker than 20 seconds. So that's telling us it's measured in frames. So then we can come in here and adjust that to a frame measurement. I can't remember where to look, but somewhere I'm guessing over here, it's 60 frames per second. But I'm trying to remember, I can't remember where to look to see that exactly. By default, it's at 60 frames per second. Somewhere in the interface here should say that. Around the backgrounds. Oh, animation speed is 30 frames per second. So it's currently running at 30 frames per second. And speed that up, slow it down. Just have to actually unlock it to do so. But 30 frames a second, so probably want to wait about a half second. Right? That seemed like a good amount of time. As you all don't know what's at the bottom of the screen, so there's some more challenging things coming still, something to make it so. So 30 frames in a second. So if we generate another castle somewhere between 20 and 60. So between a second and 2 seconds, so there's gaps between them. A long gap will apply to something down here at the bottom of the notes I put together. We'll see that in a few moments. Some go somewhere between roughly a half a second. Oh, that would be 2 seconds. Yeah, a half second and 2 seconds. That sounds like a good amount of time. And I want to make sure and change both those alarms. 20 to 60 on that one and 20 to 60 on that one. Does the idea of the timer make sense there? Whoops. Control S to save. So we just set how many frames we want to wait. And frames can be a nice way to measure things in games because we know that's always ticking away when we have those graphics and animations and things. So it's not the traditional measurement scale, but usually it's fairly simple math to get to the traditional measurements. So that'll create more castles for us to launch fireballs at. And yeah, I guess we just need to check and make sure that position's okay. Because again, that was just a guess of a starting point, sort of the general region. But after a quick run, we'll have a more precise measurement of make little adjustments and see where that needs to start. And the general rule of thumb in programming is run a check every chance you get. Oh, looks like that fireball's only barely reaching those. And that's showing up a little bit too quickly, isn't it? Probably don't need that many castles. So I'm going to make a couple adjustments. There's one time it looked like the fireball missed it. So where it creates it, I'm going to move it up a little. Remember, positive Y is downward. So a negative decrease in the number moves it up the screen. 0, 0 is in the top left, I guess. And then X goes up as we move right, and Y goes up as we move down. Which again, if you can't remember that for the particular thing you're working in, that's a really easy thing to check. Just put something at 0, 0 and see which corner of the screen it shows up in. Oh, and instead of starting 280 over, I'll just start like 20 over or something. That way it's almost at the left side of the screen. It looks like it just appeared there. But I destroyed it on, well, wherever that was. We set the castle to destroy itself when it's outside the room. So we don't want to start it completely outside the room. We want to start it inside the room somewhere. And while I'm here, while I'm zoomed out, I'll drag this over. And personally, the organization I like here is I usually line control objects up with the background. That's just the way my mind categorizes them. You might feel a little bit different, but organization definitely goes a long way because we've filled up about half the screen, zoomed all the way out, and there's barely anything here, right? So any decent sized game, there's going to be a lot of parts there. So organization will go a long ways. Let's see. That'll create castles. It seemed to be doing that awful quick though. Whoops. And remember, you get different scroll wheels and stuff depending on where your mouse is, like I just did there. So I'm going to increase that. I was thinking half a second to 2 seconds would work, but that went awful quick. So I'm going to switch that to 1 to 200 frames. That seems long when I do the math in my head, but it's 20 to 60 was showing up really, really quick. So I'm going to increase that quite a bit. 1 to 200 frames might work. Because there's also going to be a challenge. The very last thing on the thing, instead of our dragon just jumping to that other position, the dragon, we have to control the flight. So the dragon's going to go up and down, and then we have to be in the right spot to hit the castle. Wanted to make sure there's a gap between the castles to adjust that. What was on the notes? Refine position and timer. Yep. Give that a run. And control objects can be very, very important. You can do a lot of things in the control objects. So that's definitely something you want to practice around with. And you can see one of the best things about game dev is there's a lot of playing games as we run tests and stuff. All right, it looks like we can destroy the castle. Right now we just have that other position, but we can also miss it if we're in the wrong spot. So like if I fly up too soon, completely miss that castle, miss that one. So we can hit it or miss it, kind of have to be in the right spot, which here before long will make it a little more challenging to be in the right spot. But it looks like we can kind of destroy castles for days and days and days, right? Oh, I'll wait till the Zoom video gets less jumpy. Yep, lean back and forth, and it's still, it takes it a moment. That's probably a little bit better. Yeah, okay. Still somewhat jumpy, but next thing we want to do is probably be nice to keep track of how many castles we destroyed. So that'll be a score object, but it looks like 2 o'clock, so we've been at this for an hour, so now might be a good time for a break. Oh, and real quick here. Because of all those temporary files, while I take a break, I'm going to go ahead and make sure I hit Control S, everything's saved. I'm going to close this and clear out of all those temporary files. Because, well, now I have to restart the software after a short break, but all those temporary files are out of the way, so they won't be slowing anything down. It cleans it up afterwards. So whenever you're taking a break, and this is something that's going to apply to most of our game engines, pretty much any game engine as an interface has all that temp stuff going on in the background. When you take a break, go ahead and close it. You'll have to restart it afterwards, which on some of them, Unity and Unreal, can take a moment to load up, but it'll be more, it's worth it to get that temp stuff out of the way, especially as games get big and there's lots of temporary files. But why don't we go ahead and take a break, and then we'll add in a score. Then draw the score, show the score on the screen, and then we'll switch it so our dragon, there's more controlled flight. Instead of just jumping to that position, we have to control the dragon to fly at that right position to hit the castles. Which just a couple steps afterwards, but does 10 minutes sound good to everybody?
Yeah, that sounds good.
All right, so we'll get back to it at 2:12, and I'm going to go get a cup of coffee, and I'm going to mute my microphone because, well, the necklace type microphones are really, really loud with a cup of coffee. But I will see y'all in just a moment.